Imagine stumbling upon a black hole that's ballooning in size at breakneck speed, lurking in the cradle of the cosmos itself. That's the jaw-dropping revelation unveiled by the James Webb Space Telescope. And this is the part most people miss. It's shaking up everything we thought we knew about how the universe's most mysterious beasts came to be. A team of astronomers, harnessing the power of the collaborative James Webb Space Telescope, a joint effort by NASA, the European Space Agency, and the Canadian Space Agency, has pinpointed a supermassive black hole nestled within a galaxy dubbed Canex LRD Z8.6. This galaxy stands out as one of the most remote we've ever glimpsed, captured by Webb as it existed a mere 570 million years after the monumental Big Bang that birthed our universe. Now, for those just dipping their toes into astronomy, let's break this down a bit. Canex LRD Z8.6 belongs to a fascinating group of galaxies known as little red dots or LRDs. These are tiny, dim specks that appear reddish because their light has been stretched out, a phenomenon called redshift, into the infrared part of the electromagnetic spectrum. This stretching happens due to the vast distances they're from us, making them look like faint, crimson pinpricks through our telescopes. Since Webb launched and began operations at the Sun-Earth Lagrange Point 2 in July 2022, its exceptional ability to detect infrared light has led to the spotting of dozens of these elusive LRDs scattered across the cosmos. In this particular case, the team zoomed in on Canex LRD Z8.6, which resides within the MAX J1149.5 plus 2223 galaxy cluster. To get a closer look, they employed Webb's near-infrared spectrograph, or NIRSpec for short, a tool that breaks down light into its component colors to reveal detailed information about distant objects. What they uncovered was evidence of a black hole that's not just sitting there, but actively accreting material, meaning it's sucking in gas and dust at a furious pace, growing larger by the day. But here's where it gets controversial. This discovery flies in the face of our current models for how galaxies and black holes sprout in the early universe. Lead researcher Roberta Tripodi from the University of Ljubljana's Faculty of Mathematics and Physics, along with colleagues at the Rome Astronomical Observatory, described it as truly remarkable. She explained, "We've observed a galaxy from less than 600 million years after the Big Bang, and not only is it hosting a supermassive black hole, but the black hole is growing rapidly, far faster than we would expect in such a galaxy at this early time. This challenges our understanding of black hole and galaxy formation in the early universe and opens up new avenues of research into how these objects came to be." Diving into the details, the galaxy's spectrum, essentially a fingerprint of its light, showed signs of highly ionized gas, which is gas that's been stripped of electrons by intense radiation. What's more, this gas was whirling around the galaxy's core at dizzying speeds, a clear clue pointing to a supermassive black hole at the heart of it all. By analyzing the NIRSpec data further, the researchers estimated the black hole's mass, revealing it was heftier than any other supermassive black holes we've found from this primordial era. Adding to the intrigue, the galaxy itself hasn't churned out many heavy elements yet and remains quite compact, suggesting it's still in its toddler phase of development. The team also examined other aspects of the data, like the energy patterns across different wavelengths, to paint a fuller picture of the galaxy's characteristics, from the total weight of its stars to how that stacks up against the black hole's mass. Co-author Dr. Nicholas Martis from the University of Ljubljana chimed in, saying, "The spectral features revealed by Webb provided clear signs of an accreting black hole at the center of the galaxy, something that could not have been observed with previous technology." What makes this even more compelling is that the galaxy's black hole is overmassive compared to its stellar mass. This suggests that black holes in the early universe may have grown much faster than the galaxies that host them. To put this in perspective, think of it like this: usually, a supermassive black hole's size correlates with its host galaxy's mass. They grow in tandem, like partners in a cosmic dance. But Canex LRD Z8.6 bucks that trend. Even though it's one of the bulkiest galaxies spotted from that time, its black hole is disproportionately massive. The team's theory? black holes might have popped into existence and started expanding at lightning speed in the universe's youth, leaving their galaxies in the dust. This idea is provocative because it implies black holes could form independently and dominate early on, potentially altering how we view galaxy evolution. Picture it as a black hole racing ahead like a sprinter, while the galaxy lags behind like a walker, defying the usual expectations. Co-author Professor Marusa Bradak of the University of Ljubljana added, "This discovery is an exciting step in understanding the formation of the first supermassive black holes in the universe." The unexpected rapid growth of the black hole in this galaxy raises questions about the processes that allowed such massive objects to emerge so early. As we continue to analyze the data, we hope to find more galaxies like Cannax LRD Z8.6, which could provide us with even greater insights into the origins of black holes and galaxies. Indeed, Webb's findings have sparked more mysteries than they've solved, prompting the team to schedule additional observations with Webb and the ground-based Atacama Large Millimeter Array, ALMA, in Chile. ALMA's radio waves will help probe the galaxy's cold gas and dust, offering clues about its other properties. Looking ahead, Webb is set to keep unearthing LRDs during its mission, aiding scientists in mapping the early universe and deciphering how black holes influence their environments, eventually blossoming into brilliant quasars, those blazing beacons powered by supermassive black holes. The results, detailed in a paper by Tripodi and her colleagues, hit the pages of Nature Communications on November 19. The data stem from the Cannax collaboration and Webb's observing program number 1208. But here's the real kicker for debate. If black holes can grow so explosively fast in the universe's infancy, does this rewrite the rules of cosmic history? Or could there be alternative explanations, like mergers or unseen influences, that we are overlooking? What are your thoughts? Do you agree this challenges our fundamental ideas, or is there a counterpoint I'm missing? Jump into the comments and let's discuss.